Our last quantum number is going to be ms, the spin of the electron. Now ms can have only two values, 1/2 or -1/2. Now there's a long interesting history behind magnetic spin. Basically the big thing is we don't actually know what it is. We know that electrons have the property called spin, and we call it spin because it looks like angular momentum. So if you take a bike wheel and you spin it, and you hold it in your arms, and as it's spinning along you try to turn it, you notice that there's a resistance to you turning it, and that's the centrifugal force, that's the centrifugal motions. Similar thing is true with electrons. Electrons act like they're spinning like tops in magnetic fields. But the problem with this analogy is that it never loses energy. It acts like a perpetual motion machine, and we don't know why. So we crudely use this idea of spin. Now, in general, any unpaired electron, and we'll go through an energy filling diagram what that means, but an electron that's by itself, meaning it has its own atomic orbital, is going to have a spin of 1/2. Only if we have to pair up electrons, meaning that we have to have two occupying the same atomic orbital, do we see this -1/2 show up. So in terms of our address analogy, we've got the house with our M sub L, we've gotten our street with our L, and we've gotten our city, state, and zip with our N. This is going to specify the roommate, which one we're dealing with. Now, if there's only one person living in a house, you don't really have to specify the roommate, right? Because it's just one person. That's basically why we say it's always spin 1/2. 1/2 means residence. The -1/2 only comes into play if we have more than two electrons sitting in an atomic orbit. So what are some of the properties of magnetic spin? Well, the big thing is that it is affected by magnetic fields. So how we used to describe these was a spin up versus a spin down. And you'll see these represented by how we draw electrons. But the idea with a spin up electron is that if we have a magnetic field represented by the letter H and it points south north, a spin 1/2 electron is aligned in the direction of the magnetic field. So if we apply a magnetic field, this electron is going to turn up and it's going to align perfectly with it. If we have a spin 1/2, it's actually opposing it. So anything defined with a spin -1/2 opposes a magnetic field because it has to spin the opposite direction of its partner electron. But in terms of any other information, we don't really have any. We don't actually know what spin is. We don't have a good way of describing it. And actually, there's been a push to get rid of these spin 1/2 and -1/2 in our nomenclature because it's a little bit misleading. But for this class, just recognize spin only has to be 1/2 or -1/2, and typically it's 1/2 unless the two electrons are paired up.